Howdy folks. We are going to talk about factoring. We're going to start this section on factoring, and there are 6 different kinds of factoring that we want to talk about. And in this particular video, we're only going to talk about the first one, which is called the greatest common factor. So I'm basically just going to show you how to remove the greatest common factor from an expression, from an algebraic expression. Now, in order to understand that, first you need to understand what a factor is. A factor is just anything that is multiplied by something else. So, for example, if we have the multiplication problem, 4 times 5 equals 20, okay? In this particular case, 4 is a factor and 5 is a factor. That's why we call, when we break a number down, like if we take the number 20 and break it down into its prime factorization, 20 can be broken down into 5 and 4. 5 is prime. 4 can be broken down into 2 and 2. 2 times 2 is 4. 5 times 4 is 20. 5 and 2 are both prime, so the prime factorization of 20 is 5 times 2 times 2. Those are all of the prime factors of 20. Okay, they are all numbers that when multiplied together will give you 20. Well, also when you multiply 5 times 4, that also gives you 20. So 5 and 4 are factors of 20. So what we're talking about here is identifying something that is multiplied by something else to equal an expression. So I have some examples here. Let's look at 1 or 2 of them. Okay, so let's say we have the expression 6x squared minus 12x plus 15. Now, in order to factor anything out of an entire expression, it has to be able to be divided, because we're undoing multiplication. To take a factor out, that means to undo multiplication. And undoing multiplication means division, right? Okay, so we need to divide something out of each one of these terms. And if you can't divide out of even one of the terms, then it is not a factor of the entire expression. So if we look at this, here's what you're going to be looking for. The first question that you want to ask yourself is there a variable in every term? There's a variable. There's a variable. This term does not have a variable. Therefore, there is no variable that is common to the entire expression, so we are not going to take a variable out of this expression. The next thing you want to ask yourself is there a number that can be divided into, and we're talking whole numbers here, divided into this number, and this number. And if we think about 6, 12, and 15, we know that all 3 of those numbers can be divided by 3. And so we know that 3 can be divided out of all of these. Therefore, the greatest common factor in this case is just 3. It's not going to have a variable with it because there's no variable in this term for 15, right? So it's going to go 3. The way we write it is we put the greatest common factor on the outside, then we put a parenthesis, then we divide each term by that factor. So 6 divided by 3 is 2. And then we're not taking out any variables, so we're just going to carry down the x squared. Negative 12 divided by 3, that's negative 4. So we're going to put negative 4, and then we're going to bring down the x. And then 15 divided by 3, that's 5. So that's plus 5. So this is our answer. You always put the greatest common factor on the outside, then in parentheses you put all the leftovers after the division. Okay? So let's try another one. Let's do 3x to the 4th plus 7x to the 3rd minus 9x squared. Okay? So in this case, again, we're going to look, is there a variable in every term? There's x to the 4th here, there's x to the 3rd here, and there's x squared here. So there is a variable in every term, so that means that we can factor out a variable. Now, you have to ask yourself, well, what am I going to factor out? Am I going to factor out x to the fourth, x to the third, or x to the second? You always factor out the smallest number of the variable, the smallest power of the variable. In that case, it's x squared. So we are going to factor out an x squared. Now we're going to look here. We got a 3, a 7, and a 9. There is no whole number other than 1. There is no whole number that goes into 3, 7, and 9. Therefore, we are not going to take out any whole number. We're not going to divide out any whole numbers from this. We're just going to take out the x squared. So we write our greatest common factor. We open a parenthesis. Then we divide. There's a 1 in front of this x. 3 divided by 1 is 3. X to the fourth divided by x squared is x squared. Remember, we subtract the exponent when we divide. 4 minus 2 is 2, so that's x squared. Positive 7, so plus 7 divided by 1 is 7. X to the third divided by x squared. Well, 3 minus 2 is 1, so that's x to the first power, or just x. Then we have minus 9 divided by 1 is going to be negative 9. And then x squared divided by x squared, well, that's 1. They cancel each other out, and therefore we're not going to put any x's on here. And if you do it correctly, then whatever is inside the parentheses is not factorable with a greatest common factor. Okay, so look, variable, variable, no variable. It looks like we did it correctly. Okay, all right, let's see here. We got 15, let's try 15y squared minus, that's 15y to the fifth. 15y to the fifth minus 20y to the third plus 50y. Why don't you try this one on your own? Go ahead and pause the video right now and see if you can figure it out. All right, so let's see if you got it right. In each one of the terms, there is a variable. We've got a y here, and a y here. Now, what is the smallest number? Well, there's 5 y's here, there's 3 y's here, and there's 1 y here. So we can only take 1 y out. So we'll take a y out. Is there a number that divides into 15, 20, and 50? Well, 5, right? Okay, so 5. So we're going to factor out 5y. That is the greatest common factor. And then we'll open up parentheses. 15 divided by 5 is 3. Y to the fifth divided by y is y to the fourth, because 5 minus 1 is 4. Negative 20 divided by 5 is negative 4. Y to the third divided by y is y squared. And 50 divided by 5 is 10. So that's plus 10. And then y divided by y, that cancels out, so there is no y on this one. And here's what we have left. Okay? Hopefully you got that right. Let's do just a couple more. And I have one more thing to show you about doing a greatest common factor. One more thing to show you. Let's see here. Let's say that we have negative 8a to the 7th power plus 6a to the 5th power plus 14a to the 4th power. So the first thing that we're going to do is we're going to look, is there a variable in every term? Yes, there is. What is the smallest number of that variable? 7, 5, or 4. 4 is the smallest. That's what we're going to factor out, a to the 4th. So we're factoring out a to the 4th. Now let's look. We've got an 8, a 6, and a 14. What whole number divides into all of those numbers? Well, 2 divides into all of them. So we're going to factor out a 2. However, wait just a second. When an expression on its highest power in the front has a negative, you should divide out, you should include that negative in the greatest common factor. You should also divide out the negative. So instead of taking out a 2, we're going to take out a negative 2. So we're going to put negative 2. So we've got negative 2a to the 4th power. Negative 8 divided by negative 2 is positive 4. a to the 7th divided by a to the 4th is a to the 3rd. 6 divided by negative 2 is negative 3. A to the 5th divided by a to the 4th is just a to the 1st, right? 14, positive 14 divided by negative 2 is negative 7. And then a to the 4th divided by a to the 4th, well, those cancel, so we're not going to have any variables on that last one. And this is our final expression here. Now notice, it's important for you to understand that this is equal to this. It's equal to negative 8a to the 7th plus 6a to the 5th plus 14a to the 4th. These are equal expressions, but this one has had a factor taken out of it. It's also important to understand that if you were to distribute this greatest common factor back in, if you were to multiply it back into all of the terms, the answer would be what we started with here. Okay? I've got one left for you, one example, and I want you to try it on your own and see how you do, and then we're done. Let's say we have negative 12x to the 4th minus 8x to the 3rd power plus 20x to the 2nd power equals. Okay? Why don't you try this one on your own? Go ahead and pause the video, and then we'll go over it. Okay, so hopefully you had a chance to try this one on your own. Let's look at all the terms. Is there a variable in every term? Yes, x. So we're going to take an x out. How many x's? Well, here's 4 x's, here's 3 x's, here's 2 x's. So we're going to take 2 x's out. So we know that x squared is going to be included in that greatest common factor. Now, what number goes into 12, 8, and 20? The largest whole number that goes into 12, 8, and 20. Now, you might have been thinking 2, but there's a larger number than 2 that goes into all these numbers, and that number is 4. 4 goes into 12, 4 divides evenly into 8, and 4 divides into 20 as well. So we're going to take out a 4. But is it going to be a negative 4 or a positive 4? Well, to determine that, you need to go to the front at the highest power of the x. Is there a negative there? There is. So instead of taking out 4, we're going to take out negative 4. So we're going to put a negative 4 here. So our greatest common factor is going to be negative 4x squared. So we're going to divide each of these terms . So we're going to divide each of these terms by negative 4x squared. Negative 12 divided by negative 4 is 3. X to the 4th divided by x squared is x squared. Negative 8 divided by negative 4 is positive 2, so we're going to put plus 2. And x to the 3rd divided by x squared is x to the 1st power, so just x. And then 20 divided by negative 4 is negative 5, so minus 5, and then x squared divided by x squared cancels out. And so this should be our final answer.